Hey everyone, hope you're doing well. This is going to be our video for the last lesson of Unit 5, and that is triangle midsegments. All right, so we're almost done after this. We're just going to review, and then our test will be in about a week. So what is a triangle midsegment? Okay, so a midsegment of a triangle is a line segment, right? That makes sense because it's segment is in the name. So it's a line segment that connects the midpoints of two sides of a triangle. Okay. So it's a line segment that connects the midpoints of two sides of a triangle. So we're going to be bringing back a lot of things here, all right? Most notably, some of our graphing stuff. So let's look at this. So we're going to do some examples here, and we're going to kind of discover some properties about the midsegments of a triangle, right? So this says plot the point 0, 8, 6, 0, and 0, 0 to create a triangle ABC, okay? So let's say, that we want this to be the X and Y axis right here, okay? Let's make this a little bit thicker. Okay, so this is the x-axis, this is the y-axis. All right, so we want to plot the point. So A, we want to be at 0, 8. So we need to go up 8. So there's A. And we want B to be 6, 0. All right, and then C at 0, 0. So this won't be too hard to do because, all right, most of the sides are, actually, let's get a different color. Most of the sides are straight, so this is actually going to be fairly easy to figure out. The only thing we are going to have to do a little bit of work for right here is the length of AB, okay? What is the length of AB? So remember how we do this, all right? We kind of make, well, actually, we already have the rise and the run, right? This actually is a right triangle, so we don't even need to do it. We can just count over 1, 2, 3, 4, 5, 6. So this is 6, and then up is 8. All right, so we have a triangle here. So we've got 6 squared plus 8 squared equals C squared, right? Because this is actually a right triangle. So 6 squared is 36, 8 squared is 64, 36 plus 64 is 100. So it looks like this is actually going to be a whole number for us, which is nice. The square root of 100 is 10. So AB is 10. Okay. Now they want us to find the length of the midsegment. All right. So in order to find the midsegment, first we have to find the midpoints, right? Because remember, it's connecting the two midpoints. Now, luckily for us, we don't have to actually do the midpoint theorem, because it actually has a midpoint that we can just count. Similar up, we can just go, I think, up 4. Yeah, so those are the two midpoints, all right? So the mid-segment is actually the line connecting the two midpoints, okay? And so we can figure out the length of that line by kind of doing the same thing that we just did. This is up 3, this is up 4, right? So we can do the Pythagorean theorem with 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And again, we have a whole number, so we can square root that. So the length of the mid-segment is 5. So immediately, what do you notice here, right? 5, 10, it's about half, right? The other thing that you can do is you can actually find the slope of both these lines. And we can do that by using the same numbers that we used above, so rise and run. Now, both these lines are negative, so if we go from A to B, this is actually going down 8, right? And then over 6. So our rise is down 8 and over 6. That's negative 8 over 6, which simplifies to negative 4/3. And then the slope of the mid-segment actually is down 4 over 3. All right, so we've got a slope of negative 4/3. So again, what do we notice here? We notice that they're the same, okay? So 2, I want you guys to actually do 2 on your own. See if you can figure out, all right, a similar things to what we found above. All right, so pause the video, try number 2. Okay, hopefully you tried number 2 on the own, and hopefully you got the same results that we did, because this is actually called the mid-segment theorem. All right, the mid-segments theorem says the segment connecting the midpoints of a triangle is parallel to the third side, right? That's what it means, that they have the same slopes, and is half as long as that side. Okay, it's half as long. So these are 2 facts that you should know. Okay, the mid-segment, it's parallel to the third side and half as long. All right, so we're gonna do 2 examples here. Okay, says suppose DE is a mid-segment of triangle ABC. Find the value of x in each problem. So in this problem, this one's not too difficult, because we know the mid-segment is gonna be half as long as that right there. So what we can do is we can set x plus 2, all right, equal to 26, but we have to change it a little bit, right? Since x plus 2 is only half of 26, we have to, double this, right? 2 times x plus 2 equals 26. So what does that mean x plus 2 equals? Well, if we, divide by 2, then x plus 2 is 13. Subtract 2 on both sides, and we get x equals 11, okay? So that one's easy, okay? X equals 11. This one, is not as obvious, all right? And that's because we haven't really gotten to similar triangles yet, so you're just gonna have to believe me when I tell you this, all right? Basically, this triangle here, everything is half as big as the whole triangle. So EC, right, just this side, EC, is half as big as AC. Okay, so what that means, well, actually, we already know this because it's the midpoint, so I just kind of explained stuff that I didn't need to. I just thought of a better way. If this is the mid-segment, all right, then that means E has to be the midpoint, which means both sides are the same, which means 6 equals 5x minus 4, which means we can solve for x. Triangle similarity, that's stuff that we'll get to later, which means x equals 2. All right, so that's how you would kind of do that problem. So hopefully you can do all your practice based on these notes. I try to make these notes not too long. If you have any questions, let me know, and have a great day.